Raw information often exists as a scattered, inaccessible mess. But when we snap those data points into a grid, we create a rigid, searchable system. We will transform a blank code editor into a functional college database using SQL. This table is our target. It organizes individual student records into clean, distinct columns for things like roll number, name, and city. To follow along, open your SQL workspace. If you don't have one installed, any free online SQL compiler will work. Understanding how a database operates begins with writing the very first line of code. Start by typing Create Database College, and then right below that, type Use College. Notice how we end both lines. In SQL, a semicolon acts as the mandatory termination point. Without it, the system won't know where one command ends and the next begins. Run that code and check your output console. You should see a success message confirming your new environment is live. Establishing and selecting this database creates the foundational container for everything we build next. Now we will build the internal structure of that container using the Create Table command. We'll name this table Student. This code is our architectural blueprint. Every column needs a name, data type, and constraint. Data types restrict information. Int limits to whole numbers. Varchar allows text. Finally, applying a primary key to the roll number creates a mandatory unique identifier that completely prevents duplicate entries. Pay close attention to the syntax here. You must place a comma between every column definition, but leave it off the very last one. This strict schema acts as a permanent shield, which is exactly what prevents corrupt or mismatched data from entering your system later. With the structure ready, we can populate the table using the Insert Into command. This script demonstrates batch insertion. We list target columns once, then provide multiple student records as values. These values must map perfectly to the column sequence. If roll no is listed first, the first value in every row must be that ID number. Take note of the formatting. Numbers stand alone, but text data must be wrapped in quotation marks. Executing this command is the bridge between an empty framework and a usable asset. Now type select asterisk from student and run it. The asterisk retrieves every column and row, confirming all 6 records are correctly stored. While viewing the whole table verifies your progress, the real utility of a database comes from isolating specific information. Adding a where clause applies a strict mathematical condition to your query. For example, where marks greater than 80 forces the database to filter the list and return only the high-performing students. A database earns its keep through this retrieval process. Whether searching 6 records or 6 million, the logic to extract targeted insights remains the same. You have successfully navigated the core create and read operations of a relational database. Test your new skill immediately. Try writing a custom filter to find only the students who live in the city of Delhi. From here, the next step is learning to alter that data. That involves using the update command to fix errors and the delete command to remove old records. By writing these commands, you've moved from simply reading information to defining the logic of how that data is stored and filtered.